Alright, we're going to work our way through different substitutions, and these will be fairly quickly. They're fairly cut and dry. And we're going to start with homogeneous equations. And homogeneous equations, if our differential equation is set up like this, in standard form, if f of xy can be expressed as a ratio of y over x, then it's homogeneous. And that's really what we're talking about when we say that. Is if we run to the solutions, we'll get dy over y equals dx over x. We'll get two ln's. We'll get e. They'll end up being y equals x type on the level of that. Or you could say, hey, the same things are on the ratios of each other. The change in y is related to y itself directly, and the change in x is related to x directly. However you want to think about it, that's where the homogeneity is homogeny. There we go. Where the homogeny is coming from. All right, so let's look at an example and explore this a little bit. So if I have the differential equation x minus y dx plus x dy equals 0, I'm going to rewrite this. X dy equals, this is going to be a negative sign, but I'll put it through there like that, right? And then dy dx is equal to y minus x over x. And so I write this, I get y over x minus 1. And this is a function of y over x. This whole thing is a function of y over x. Let's make a test then for homogeny. It's a slight change from the homo to the homog that I always mess up saying homogeny. Then let's make a test for a homogeneous equation. And that test has to do with how this ratio will be unaffected by a multiplication. Right? If I multiply x by t and y by t, well, if it's homogeneous, the t's will cancel. And so this should equal the original equation. That'll be my test. So let's run the test here and see what we get in a function. So if I have x minus 2y minus 1 dx plus x minus y dy equal to 0. And I'm going to run through the same thing. I'm going to have x minus y dy equals, and I'm going to switch the signs here as I go through, so it's going to be 2y minus x plus 1. I hope you're okay with that. As I'm subtracting something, I'm switching the signs. And so dy dx is equal to 2y minus x plus 1 over x minus y. Well, let's run our test here. I mean, I could do some weird factoring tricks. I could see what I could do, but let's take this as being my f of x. So f of x is equal to 2y minus x plus 1 over x minus y. And I'm going to look for f of tx ty. I'm going to multiply it by a factor. So I get 2ty minus tx plus 1 over tx minus ty. Well, there's one term here. I can pull out t's, but I can't get them to cancel. And so this is not. This is not homogeneous. It fails homogeny. It fails a test for homogeny. All right, well, let's look at solving homogeneous equations then. So we can do this by making substitutions. Substitutions is the name of our game, and our substitution is really going to involve what we tested for. And so let's come in, and let's say we have our differential equation in standard form, and we're going to say, hey, we're going to let v equal y over x, which means that our function can then become some function of v. And so to do this, we're going to have to say, hey, this means y equals v of x, and if I do dx of this whole thing, and then dy dx is equal to, well, the first times the derivative of the second, so that's v dx dx, plus the derivative of the first times the second, and so dy dx will equal v plus x dv dx. Well, that can change our differential equation up here. That means v plus x dv dx equals g of v. And this is separable. I can do x dv dx equals g of v minus v, and I can then do dv over g of v minus v equal to dx over x. And so we've made this homogeneous equation separable, and so that's really what our technique does. And so what we want to do is we want to exploit this and do our substitutions to make this technique work for us here. So let's come back and let's do a full worked out example. I think bright purple. I'm in a bright purple mood. Alright, so y squared minus xy dx plus x squared dy equals 0. Now I'm going to get this in standard form, and I'm going to isolate my function for my differential, and we'll analyze that function to make sure it's homogeneous, and then we'll apply the substitution if it is. So I get x squared dy is equal to, again, I'm changing my signs as I move it over, dx. Dy dx is equal to xy minus y squared x squared. Xy minus y squared x squared. Well, if this is f of xy, then in f of tx ty is equal to tx times ty, right, because I'm dropping tx and ty in here, minus ty squared over tx squared. Now I can pull out a t squared here, and I can definitely pull out a t squared there, so I'll get t squared xy minus y squared over, and my square should be outside of the parenthesis here, t squared x squared, they cancel, and I'm left with what I started with. So this is homogeneous. And so I can make the substitution, and so we'll begin with substitution. So I'll change colors. I really want to be a bright, obnoxious green. I just can't find the bright, obnoxious green I like. We'll try this. So we'll say V, ooh, that is obnoxious. v is equal to y over x, which means y equals vx. And what we're going to do is we're going to come here and we're going to replace this. We also get the relationship we had above, which is dy dx equals v plus x dv dx. And so I'll substitute into my differential equation v plus x dv dx equals x times vx, because that's replacing that, minus vx squared over x squared. Alright, so let's clean this up a bit. So v plus x dv dx equals, well, I've got an x squared here, so I'll pull out an x squared, v minus v squared over x squared, and they'll cancel. And I'm going to come over this way. And so I get v plus x dv dx equals v minus v squared. Well, I'll subtract this v from both sides, and I'll get x dv dx equals negative v squared. And let me make sure I flip the page here. I get negative dv over v squared equals dx over x, or what do I want to get? I get 1 over v equals, oh, well, I'll integrate these. And 1 over v equals the natural log of x plus c. And so I'll solve for v. I'll say v is equal to 1 over ln of x plus c. But v was y over x. Remember, that was the substitution we started with? Seems so long ago. And then y equals x over ln x plus c. Now some things to note. We divided by x and by v squared, which meant we divided by y. So we lost solutions where x is 0 and y is 0. And so we have to keep these in mind for our solution sets and possible solutions. And that is homogeneous equations. Ratios of y to x.